Okay, wake up. Take a big breath. Okay, we're going to start some science today. We're going to talk about all the forms of energy that we have been talking about, like potential energy and kinetic energy. And our learning target today is I understand there are many forms of energy. So we are going to put kinetic energy, forms of kinetic energy here, and forms of potential energy on these lines. These are called a graphic organizer, right? So it's organizing in a picture. So you're going to use notebook page 25 and 27 to complete these graphic organizers. But first, we are going to review as a class. So let's look back at page notebook 25. We have potential energy in gravitational potential, elastic potential, chemical potential, electrical potential, thermal energy, and nuclear energy examples. Woo! Okay. And on page 27, we have electrical, radiant, sound, and mechanical and thermal energy. Uh-oh, you say. Maybe you already caught this. Thermal energy is in two places, in kinetic energy and potential energy. Let me offer you an explanation for that. So, to explain that, I'm just going to use my pen. So, my pen has thermal energy because the molecules in my pen are moving. You might remember when we talked about states of matter, solid, liquid, gas, and we talked about the molecules in them moving, right? So the molecules in my pen are currently a solid, right? I'm just going to talk about just the plastic. It's a solid. So the molecules are definitely moving and they're vibrating, right? And that movement is at a molecular level, very, 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 very tiny. Okay, but that motion is still there. So that motion is thermal energy, and that motion is kinetic, right? But now here is my pen, and if I drop it, it has potential energy, right? So if I drop it, it's going to cause friction in the air, right? Even though you can't see these molecules here, they're here, right? We just took a big breath and that moved our air, right? But so air has molecules in it too. So when this pen actually falls, it has kinetic energy, right? Even not even falling, it has kinetic energy because of the molecules in it. But it has potential energy right now because of its position, right? So it has thermal and potential energy. And really anything that's made out of atoms has thermal energy because atoms are always moving. Okay? So we're just going to go with that. So kinetic energy is thermal energy and potential energy is also thermal energy. I'll try and be very clear when I ask you to determine whether thermal energy is kinetic or potential with the situation. Okay? All right, so together I want to practice all these forms of energy. So we're going to look at and I drew this for you. Yay. So hopefully you can see most of it. Okay. So here we have a playground. We've got some clouds and lightning. We've got some electrical power lines going on. We've got a nuclear power plant. We have some street lamps to light up our playground here with people talking to each other, playing on the merry-go-round, zipping around in the wheelchair, coming down the slide, playing on the swings, talking to each other. Got some trees back here with some fruit growing on it. Got some people talking. Got a slingshot going on over here. I don't know what he's aiming at, but I hope it's not us. All right, so got a lot of stuff going on in this picture. So I'm just going to ask you about specific kinds of kinetic energy at this point. So remember, kinetic energy is energy of motion. All right? So please find me some thermal energy. I'm going to pause the video and then I'm going to call on you to ask if you would please identify in this picture where you could find thermal energy. Okay, so if you were looking for thermal energy, remember thermal energy has to do with heat, and every one of these bodies has heat going on, right? And so that's thermal energy, it's heat, right? All right, so let's look for some electrical energy that is kinetic. All right, so hopefully kinetic, again, is moving. So lightning is a really good example of moving electrical energy, right? And we have electricity moving from our nuclear power plant through the wires, most likely, right? There's probably electricity moving through our light bulbs. You can see that they're lit. So there's probably electricity moving there. We might actually have some static electricity going on from the girl going down that slide. I don't know if you've ever gone down a plastic slide and gotten shocked. That's static electricity, and static electricity is electrical energy. All right, let's pause it again and look for some radiant energy. All right. Radiant energy is light, so we have radiant energy with the sun. We have radiant energy with our two light posts. Do you see anywhere else? I think those are probably the two best ones. All right, so let's look for mechanical energy examples here. We'll pause it. Okay, mechanical means motion and moving, right? Like machines. So we have a merry-go-round going here. There's definitely some mechanical energy happening. The boy is actually pushing, and this one is pulling. Those are mechanical energy. Mechanical energy we have going on with the wheels in the wheelchair. We have mechanical energy if these guys are actually climbing. There would be mechanical energy there. I'm sure in the power plants we've got mechanical wheels turning and things going on like that, and generators in there. That's mechanical energy too. Okay, so let's look at forms of potential energy. So I'm asking you to find a form of gravitational potential energy. I'm going to call on you. Okay, so if you said that these people on this climber had gravitational potential energy, you are correct. If you said the fruit before it falls off the tree has gravitational potential energy, you're correct. If you said that the guy at the top of the slide, I don't know if it's a guy or girl, not very clear. If you said that the guy at the top of the slide has gravitational potential energy because of his position, he could fall, right? That is correct. This girl also has gravitational potential energy because she is above the ground, right? So she is going to move down. So at any 1 nanosecond, she has potential energy. All right, so the girl in the wheelchair also has gravitational potential energy. She could fall out of her chair, okay, but could fall out of the swing. The actually bar across here, anything that is not actually touching the ground here that could fall, gravitational potential energy. Even you in your chair right now, wake up! Okay, elastic potential energy. Let's put a pause. Okay, the only real form of elastic potential energy that I can find really here that's super clear is this boy with his slingshot, and the elastic potential energy is in this rubber band or this rubber stretchy thing that he's pulling back. Hope he's not aiming at us. All right, everyone look for chemical potential energy. Okay, chemical potential energy. Maybe this fruit is food for something, maybe humans or birds or squirrels, or maybe you thought that they were acorns. That's potential energy, okay? That could be eaten. Or maybe the leaves on the trees actually potential energy. Even if you look at the trees, if this is wood, which it is, if that's wood, you can burn it. So it has some chemical potential energy. So we also can look into possible chemical potential energy if you're thinking about maybe one of these kids is eating. I don't know what this kid is doing, but maybe they're just holding their hands to stay in the swing, but maybe they're holding something to eat. And if they are, and if you thought they were, that's chemical potential energy. Also, the bushes, same thing, chemical potential energy. All right, the last thing I'm going to ask you to look for in this page is nuclear potential energy. If you guessed up here with the nuclear power plants, you are correct. Duh, like first things first, right? Where you're splitting atoms and containing that heat. But also, the sun has nuclear potential energy. It has lots of atoms that are bonding and rebonding, and it is powered by fusion, and that is nuclear potential energy, right? So there's some of that on the sun. All right, today you are going to take all of the examples that you know of, and you are going to put them into kinetic energy and potential energy and fill in these graphic organizers. You're going to watch a quick video by Bill Nye, and then you're going to see if you can do some reviewing on a Google form to answer some questions. Let's see how awesome you are, because you're awesome! Have a good day.